everyone, welcome to this class on equilibrium modeling. Now equilibrium theories are based on the isotherm profiles, as we have already seen in the previous lectures about the Langmuir isotherm, the Freundlich isotherm, and there are several others different isotherms. And in the last lecture we actually worked out some a problem related to this equilibrium modeling of this process. Now in this lecture 2 we will it's a continuation of the equilibrium model. We will try to work out another one or two more problems in this direction, and we will see that how the isotherm models can be fit or developed from the experimental data, and how this model can be used to predict the equilibrium concentration, or other way around, to work out how much of the adsorbent would be needed to achieve or to attain a target value of the solute concentration in the final treated solution. So again we will take a this example of an this wastewater or a water treatment solution. So we say that let us have this adsorbent as the activated carbon, which is added or which is used to remove a adsorbate, is one of the pesticides. Alachlor is a popular pesticide chemical which is very hazardous in the carbon cycle of the environment. So we try to use this activated carbon to purify or to remove alachlor from this solution. So let us say we have 6 flask or 6 containers containing 200 ml or a fixed volume of this waste liquor containing this alachlor. So let us list down the conditions. So let us say we have, I will list down the equilibrium alachlor concentration in milligrams per liter and mass of activated carbon in milligrams that is added to each flask. So let us say the first flask, all the flask has a volume of 200 ml. In the first flask we add 804 milligrams of activated carbon, and that produces an equilibrium alachlor concentration of 4.7. Similarly, in the other flask the volume is same and we achieve up 7 with equilibrium concentration of 9.3. Similarly, for the third case, on adding 512 milligrams, the alachlor concentration turns out to be 9.3. So as you can understand, as the mass of the carbon or the mass of the adsorbent is reduced, the equilibrium concentration increases, because you do not have sufficient amount of the adsorbent to actually to remove or to take up this alachlor from the pesticides or remove this alachlor. Similarly, the next one, fourth one, we have this as little bit less amount. Then we have fifth one. In all of these cases the volume of the solution is same. We further reduce the adsorbent concentration. Sixth one, this is further reduced, this amount of the adsorbent, and naturally the equilibrium concentration is increased. Now there is one more condition, that if we do not add any adsorbent, so the adsorbent is 0, the alachlor concentration is 250. So, this last one, this last row represents that 250 milligram of Alachlor, 250 milligram per liter concentration of Alachlor is actually the Alachlor concentration that is present in the liquor. So, this can be, this value is actually can be treated as the initial concentration of the adsorbate, right, because after this is the concentration that you get without adding any adsorbent. So, naturally this is the case where the concentration of the Alachlor is present in the solution, and of course, after adding adsorbent, when you measure the concentrations, you get different levels of the equilibrium concentration by adding different amounts of the adsorbent. So, now the first step, so with this is like a small experiment that is done to find out the amount of find out the Alachlor equilibrium concentration. So, from here the first question is to work out the equilibrium isotherm relation. So, we are looking for a Langmuir type model. Of course, you can use the Friendlich model also. So, the Langmuir model is given by this. So, where K and Qm are the constants, Qe represents the equilibrium concentration of the adsorbate in the adsorbent, and C represents the equilibrium concentration of the adsorbate in the solution phase. This is what is already known to you. Qm and K are the two constants. K is the equilibrium constant and Qm is the maximum capacity of the adsorbate that can be taken up by this adsorbent. Now, this is the first part. So, we have to work out what would be this constant, and the second part of this question is or the problem would be to estimate the amount of adsorbent, or essentially in this case the activated carbon needed to reduce the final Alachlor concentration below 1 milligram per liter at equilibrium. Because if you note in the problem where we have added different amounts of the adsorbent, the minimum equilibrium concentration that is attained is 4.7 milligram per liter even after adding 800 milligrams, around 800 milligrams of the activated carbon. So, the idea is that what would be to filter or to let us say to treat 200 ml of the solution, what would be the amount of adsorbent that is needed, so that the final equilibrium concentration reaches 1 milligram per liter, which is around the discharge or the environmental disposable limit for this Alachlor concentration. Now, the first work out the first part, we have to find out the values of Qe and Ce from the available data. So, this Langmuir isotherm on linearization takes the form of 1 by Qe as. So, we have to do a regression of this 1 by Qe with 1 by C, and the slope will give us K into Qm, and the intercept would give us the constants of Qm, right. So, this value of Qe would be obtained in terms of milligrams of Alachlor with per milligram of the this carbon or gram of the carbon, and the unit of K would be like the inverse of the concentration, a liter per milligram. So, now we have this. So, now the task is to work out what would be the amount of Ce values are already known to us, right. It is these values which is present, these are essentially the Ce values, these are essentially the Ce values, this is the M values, mass of the adsorbent, and this is the volume of the solution in each case. So, to find out the Ce values or the concentration in the adsorbate phase Ce, we have to, this is something we have to find it out from the from each case, then only we can make a plot of 1 by Qe versus 1 by Ce. So, to find out the CE values, we can use the mass balance relation. So, the amount that is adsorbed, right, by the this adsorbent, that is m into QE, plus the amount that is present in the solution at equilibrium, that is V into C. So, this is the total amount of Alachlor. So, this is the amount present in Alachlor in activated carbon. This is the amount of Alachlor or this adsorbate in solution at equilibrium, right. So, this is after the equilibrium has happened. So, the amount that is uptaken by the activated carbon is m into QE. QE is the concentration of this adsorbate in the adsorbent phase, and C is the equilibrium concentration in the solution phase. This would be equal to the initial concentration of this Alachlor, this initial Alachlor in solution, right. So, this volume V is 200 milliliters, C 0 is 250, this is 250 milligrams per liter, and this is 200 ml. So, this fraction is constant for all the case. So, the initial amount of the Alachlor is 250 cross this 0.2, that is the amount or the milligrams of Alachlor that is present in all the case, and with addition of different amounts of adsorbent, the equilibrium concentration is reduced. So, from there we can work out what would be the QE values in this case. So, let us try to work this out. So, then we have the mass of the adsorbent, the volume is fixed for all cases. So, we do not write that value. CE values we will write, this is the amount of adsorbent that is added, and then from there what would be the value of QE, which is nothing but C 0 minus CE into V divided by the amount of the adsorbent, and this we will be getting in terms of milligram per milligram of the adsorbate adsorbent. So, for the flask 1, around 800 milligrams of activated carbon was used, and the concentration, equilibrium concentration 4.7. So, if you work out the numbers, this turns out to be, this is 250 milligrams, this is multiplied with 0.2 liters divided by 804. So, this is 0.061. Similarly, for second case, we can work out all these numbers, and as you see, the amount of adsorbent is increasing, decreasing, the amount that is uptaken is increasing, the QE values are increasing, because the system is getting pushed more and more towards the towards its maximum limiting capacity, as the concentration of Alachlor is fixed in all the cases. This is just working out all the numbers, and finally, when you have 0 adsorbent, the equilibrium concentration is 250 and the QE value is 0. Now, from here you can work out what would be the values of 1 by CE and 1 by QE values. So, the QE 1 by QE values are calculated as obtained from inverting these values that we have calculated. So, this number is 62.8. So, if you see, or if you work out the different calculations, so this is what roughly the values looks something like this. Now, if you do a linear regression, either you can draw these points in a graph sheet and try to draw a best fit line of 1 by CE with respect to 1 by QE. Then from there you can work out the slope and the intercept. Alternatively, you can do linear regression and you can do this summation of the error residuals to find out the optimized value of these two linear regression coefficients, and the linear regression value gives you 1 by QM, which is the intercept, as 5.50, and 1 by K into QM, which is the slope, as 52.3. So, from there you can work out that QM is approximately 0.18 milligram per gram, and this constant is 0.105 liters per milligram. So, this is equal to 180 milligram per gram of the adsorbent. So, this is milligrams of Alachlor per gram of the activated carbon. So, this suggests that now we can construct, this Langmuir isotherm looks as this, and this is completing the first part. So, the second part of this problem, this part B, which talks about that now CE is set to 1 milligram per liter, right. So, in this case we have to work out what would be the mass of the adsorbent, right. So, from this exercise we can from this Langmuir isotherm, so we can work out from Langmuir isotherm, we can work out that at this equilibrium concentration at CE is equal to 1 milligram per liter, what would be the value of QE. And this is around 0.017 milligram per milligram of the Alachlor, per milligram of the activated carbon. Now, simply from mass balance, we can say that the amount that is removed, or this initial concentration, or the initial whatever is there, is equal to the final equilibrium concentration plus the amount that is uptaken by the adsorbent. So, from that theory itself we can work out that the amount that is uptaken and the amount that is present in the solution at equilibrium is equal to the amount that is present initially. So, from here we can work out that M, the requirement of M, stands out something like this, and roughly if you work out the numbers. So, this is 250, this is 1, this is 0.2, and this is 0.017. This turns out to around 2930 milligrams. So, we see that to reach a value of 1 milligram per liter, the amount of the adsorbent that is needed in this case is around 2.9 grams of the activated carbon to filter out 200 milliliter of 200 milliliter of the waste liquor containing 250 milligrams of Alachlor, and to bring down the concentration up to 1 milligram per liter at equilibrium. So, now we move to the next problem. So, the next problem we try to use a competitive or a multi-component adsorption model. So two volatile organic matters which is present in trace amount, right. So these are acetone and propionitrile, which is present in an aqueous stream, and they are to be removed using activated carbon. So these are the adsorbates, and the adsorbent is activated carbon. Now you are provided with the single phase or single component equilibrium data for both. So for acetone, let us say acetone we call it as species 1, and propionitrile we call it as species 2. So for species 1 acetone, the Langmuir isotherm is given as, so these are the individual Langmuir isotherms. For these two solutes, and now it is asked that in a so these data, this Langmuir isotherm data for these two cases is actually obtained from their individual isotherm experiments. And now it is asked that when you have a mixture of solution containing let us say 40 milligram per liter of this acetone and 34.4 milligram per liter of propionitrile, then what would be their equilibrium values? Can that be obtained and can that be compared? So now this is a problem where you have a binary solute system or a two solute system, and their individual capacities are known to us. So we have to use the multi-component Langmuir model in this case. So which is Qi, if you recall, Qim Ki divided by 1 plus the summation of all the species present in the solution. So in this case it would be 1 to 2, as we have only 2 species in this case. So now from this case, as we see, there is a this two type of equation, two constants that we have, and the numerator is essentially nothing but, so this if you recast into the form of Q is equal to Qm Kc by 1 plus Kc, then we can work out that Q1m is equal to 0.190 by 0.146. So that turns out to be around 1.3. Similarly, Q2m is 0.173096, and that turns out to be around 1.8. Now we have worked out the values of Qm for these two individual cases. Now these can be coupled together. So now you know the Ki values, K1, K2 values, Qm1 and Qm2 values. So now we can use the multi-component model. So now to work out Q1, we will use this theory of multi-component. So 1.3 multiplied with 0.146, and now we have for the first case 40 milligram per liter. So this is for the acetone case, and in the numerator we will be summing up K into C, K1 into C1 plus K2 into C2. So where the effect of the concentration of the other species will also come in the picture. So this is the value of QE in this case, Q1E in this case. Similarly, for Q2 you will be getting in the same way as 1 plus K1. So the denominator in both cases is same. So comparing these two values, this the top one is for acetone and the bottom one is for propionitrile. You can see that the uptake of propionitrile is comparatively less than acetone, and interestingly in this case it is different from their single component uptake values, because if you put the uptake values or if you compare their single component uptake values at 40 and respectively at 34.4, you will see that the values are larger. But in the case of the competitive multi component system, or when there is a mixture, as you know, there is competition of the sites for by the other molecule to absorb the same species, the relative values decreases. So I hope all of you have followed this lecture and found it useful. Thank you, and we will start this next lecture on kinetics of the adsorption. Thank you.